Alright guys, good morning. Today we're going to work on something called the Pythagorean Theorem. And I just want to show you through an example of the following squares below how the Pythagorean Theorem works. So what I'd like to start by doing is taking each of these squares and showing you that they are squares. So this one is 3 by, if we take a look here, it's 3 by 3. Okay, so this one's a square. Then let's take a look at the green one. And here we have a 4 by there you go, 4. And this last one, as you can see, we have a 5 by, there we go, a 5 by 5. Alright, so each one of these shapes is in fact a square. So what the Pythagorean theorem states, if we take the side of this square, how big is one of the sides? And I hope you are saying 3. Okay, so one of the sides measures 3. So the square measures how much? Well, 3 times 3 equals 9. So the square measures 9. And this one measures, let me move this over. This measures 4 by 4. I'm running out of space here. This green one, as you remember, measured 4 by 4. What I'm going to do is put this end here with the tip here. So the two edges are touching together. So we know that both of the length and the width measure 4 here. Bear with me if you feel a little confused. It will make sense in just a minute. And what's the square of this shape? Well, if the length is 4 and the width is 4, the square measures 16. All right, and remember, square means taking the number and multiply it by itself. So 4 squared would be 4 times 4. 3 squared would be 3 times 3. And what the Pythagorean theorem states, if you take the square of the two smaller sides, it's going to equal the total is going to equal the square of the biggest side. So if I take this large square and connect this edge here to the tip here and this edge here to the edge here, it will in fact close the shape off. I just need a minute to play with the shapes here. It's a little easier on paper than it is to try to do it on the computer. There you go. So remember, this one measured 5 by 5. All right, so if each of the sides here measure 5 by 5, what's the total area of this big blue or purple square? And hopefully you are saying 25. That's the area for this shape. So the Pythagorean theorem, if you notice, the green and the red are the smaller squares, and the purple is the largest. So it says the square of the two smaller sides is equal to the sum of the square of the largest one. So if I take 16 and add 9, what do I get? And hopefully we said 25. Okay. All right, so what we're going to do now is we're going to go the other way around. If you notice, we are looking at a right triangle. And let's assume we didn't know that this number was 5 on the longest side. So if you notice, we have two shorter sides. And those shorter sides are what we call the legs. And this longest side here, and I'll highlight it with this fun color here, This longest side here is what we call the hypotenuse. Ready? Hypotenuse. Hypotenuse. This is what we call the longest side of the triangle. I don't make this stuff up, guys. I just keep it. So the hypotenuse. So you could always tell where the hypotenuse is because it is the biggest side of the side of the triangle. So if I know this side is 4 and this side is 3, and I want to find out how long the hypotenuse is, you know that it's 5 because we've been working with it. But what if you didn't know this? How can we find it? And this is where the Pythagorean Theorem comes into place. The Pythagorean Theorem states if you take one of the sides, we'll call it A, and square it. So we can say call this blue side here with 4. We can call this leg A. And we can call this other leg down here B. So if we take side B and square it, that'll equal this whole thing here, the hypotenuse, and we'll call that C, and we'll square that. Well, what does all that mean? Well, if we take the value of one of the legs, A and B are interchangeable. I can call 4A or I can call 3A, and the other way around, I can call 4B or I can call 3B. So I'm just going to keep it in order. I'm going to take 4 and square it, plus I'm going to take B, remember number 3, and I'll square that. And what does that equal to? Well, we don't know yet, but it will equal C squared. What's 4 squared? Remember, it's 4 times 4, 16, plus, what's 3 times 3? 9. And what does that equal to? C squared. Okay, we are almost there. What's 16 plus 9? You can use your calculators for that. That equals 25 is equal to the square of C. So that means when you see it written like this, the entire square has an area of 25. But remember, I don't want the entire area. I just want to know the length of this bright red line. So yesterday we studied square roots. I take the square root of both sides. What's the square root of 25? Is 5. And the square root of C squared is simply C, because C times C equals C squared. Okay, here we are. Next we have the symbol for a radical. And this is what a radical looks like. It has nothing to do with division, so don't confuse a radical sign with a division sign. They are not the same at all. They don't mean the same. So let's take a look at the example in front of you. I have the square root of 25, which is 5. So what I did was I found out what times what equals 25. We can go the other way around. What does that mean? Well, 5 squared equals 25. The square root of 25 equals 5. What I just showed you here are opposites. Squaring a number, 5 times 5, 25. This is called squaring the number. The square root of 25 means what times what would give you this answer of 25, which is 5. So squaring, right here, and square rooting are opposites each other. Just like adding is the opposite of subtracting, or dividing is the opposite of multiplying. So let's say I have this right triangle. The legs are called A and B. They're in green and red. And we're going to try to find the hypotenuse there in blue, letter C. So let's assume that A is 6 and B is, the Pythagorean theorem states a squared plus b squared equals c squared. This is our formula. This is what you start with. So let's take the value of a, 6 and squared, plus the value of b, 8 and squared, and then squared. 6 times 6, 36. 8 times 8 is 64, and that equals to c squared. Take 36 and add it to 64, and we get 154 squared. Remember, this is the entire square. I don't want to know the entire square. I just want to know one of the side lengths. So what can I do both sides? Take the square root. Square root of 100 is 10, and the square root of c squared is c. So the missing one side times equals 10. All right, all of you should have a packet with a bunch of triangles on the front page. We're going to work on number 1 together. I'll show you how to complete the problem. Then you're going to work on numbers 2 through 10 together as a group. We'll go over the rest of the problems. So here we go. Number 1. It kind of looks like this, and the other way around. This side is 7. This side is 1. So we're going to start with the Pythagorean theorem. Squared plus b squared equals c squared. You can pick the 7 or the 21 to be called a or b. It's up to you. 7 squared plus 21 squared equals c squared. Take 7 and square it. So 7 squared is 49. 21 squared in your calculator, there is a little square button. 21 times 21, or 21 squared is 441 equals. Take 441 and add 49 to it. You get 490, and that's equal to the square of c. But I don't want the square. I just want to know how long the side length is. I don't want to know the entire square. So what do I do to both sides? So take your calculator, hit second, hit the X square button if you notice the square root key is right above it. Type in 490, hit enter. You'll probably get an answer in the calculator 7 square root of 10. Right above the equal sign, there's a little button with 2 arrows. Hit that, and you should get 22.13, but rounding to the nearest the length of the hypotenuse. All right, guys, have fun. I'll work with you guys if you need any help.